Hello, class, and welcome to Notes on page 63, Collision Review. So tomorrow I am going to give you a collision quiz that's going to be on elastic and inelastic stuff. But first I wanted to do a little review with you to make sure that you understood everything. Now, this takes up the entire page 63. Just keep that in mind. I'll let you know every now and then how far down my page I am, so you can space things out appropriately. Alright, first, overview, stuff you need to know. You need to know this idea of momentum, represented by letter P, is mass times velocity. Velocity, remember, has a direction on it. It can be positive or negative, up, down, left, right, it can be at an angle, whatever. Whatever the direction of the velocity, that is the direction of the momentum. Alright, now a little bit on subscripts. If I say, hey, this is the momentum of A, that means I'm dealing with the mass A and the velocity of mass A. Now, if I say PAI, that means the momentum of A initial, or before, as in before the crash, which means that's going to be MA times VA before the crash. All right, another thing you need to know, this idea of total momentum. The total momentum is going to be equal to the momentum of A plus the momentum of B plus so on and so on and so on for however many things there are. All right, last thing in the overview, this idea that the total momentum before the crash has to equal the total momentum after the crash. Has to. Always true. Always, always, always. Alright, so using these four general relationships, we're going to do some stuff. Stuff 1. Inelastic collisions. So an inelastic collision, in case you had forgotten, that's a sticky collision. The idea is this. I got car A, it's going this way. I got car B, it's going this way. They then crash. And then afterwards, they're stuck together. They are now one thing. Moving off together. Alright, so from now on, whenever you are doing a collision problem, I want you to draw me a picture like this. That looks just like this, but with the arrows going the appropriate directions. Then, I want you to do this. This is object A, so it has mass A. This is object B, so it's mass B. Object A and object B are now stuck together. Alright, so object A plus object B mass. Alright. Now we're going to look at the arrows, which represent the velocities. Times the velocity of A. Times the velocity of B. Times the velocity of both of them together. Now, this is the crash. This is before the crash. This is the crash. This is after the crash. Now there's only one more thing I need to do. Where it says crash underneath it, I'm going to put an equal sign. And in between these two terms, I'm going to put a plus sign. And that is my equation that I'm going to use to solve my inelastic problem. Don't believe me? Well, okay, let me rewrite this. This would be PA initial. This would be PB initial. Those two things together give me P total before the crash. This, that's P final. There's only one thing, so that is P total final. Equal sign, equal sign. Look, it's exactly the same thing as what I have up here. I am just using the conservation of momentum. So the stuff I have in blue, you are not writing that down when you're doing a problem. It's in your notes right now. But when you're doing a problem, you don't have to write that stuff. Just the stuff in red. Then you plug in your numbers, and you get an answer. All right, let's write that down. Then, as my math teacher used to say, plug and chug. You just put numbers in everywhere you know it. For the one thing you don't know, then use algebra to solve it. All right, next. Elastic collisions. Now, elastic collision, also known as the bouncy collisions. The idea here is this. You got car A, you got car B, same as before, they crash. So far, just like my inelastic collision example. But now, instead of becoming one thing, instead of sticking together, they bounce off each other and go different directions. But they don't have to. I mean, A and B, they can be going the same direction, but as long as they're not touching, it's still an elastic collision. All right, so you got this. First thing we're going to do in a problem, you're going to draw me the picture so it looks exactly like this. Exactly like this. All right, now I'm going to say, all right, well, that's MA, that's MB, that's MA, that's MB. So MA has velocity A, MB has velocity B, MA has velocity A, and B has velocity B. Here's the crash. This is before the crash, so that's before, that's before. Here's the crash. Here's after the crash, so there's after and after. Put a plus sign in between my terms, where it says crash equals. Here I have momentum of A before, momentum of B before. Add them together, you get total momentum before. Here's momentum A after, momentum B after. Add them together, you get momentum total after. You get momentum total before equals momentum total after, which is exactly what we want it to be. And then, plug and chug. You put your numbers in for what you know. The one thing that you don't know, you solve for. All right. Now, the last thing that I want to talk to you guys about, by the way, I am 4 lines below the halfway point, just so you get an idea of what I'm doing, what's going on. If yours is more condensed, that's fine. Algebra. I know that the biggest issue a lot of us are having is, all right, well, I have the equation, I have my numbers in, now what? So, I'm going to give you a step-by-step on what I want you to do, how I want you to solve problems like this, and then I'm going to do an example problem so you can see step-by-step what I'm talking about. Step 1. You got to plug in your numbers. Step 2. You got to simplify all your terms. Step 3. Move all your known stuff to one side. Do this with addition and subtraction first. Then you're going to move all your knowns, or you're going to finish moving all your knowns to one side. But this time, you're going to use multiplication and division. This order is important. When you're simplifying, you use order of operations, which means you use multiplication and division before addition and subtraction. But when you're solving for something, you're undoing order of operations. So it's kind of working backwards. You got to do it in the other order. All right. Now you have everything that's known on one side. You have your unknown alone. If at this point your unknown is not alone, you have done something wrong. Try again. So you have your unknown alone on one side. I want you to simplify the other side. And that is how you get your answer. All right, now I'm going to do an elastic collision problem. I'm just going to do it step by step, exactly what we've seen. I'm going to do each step in a different color so you can follow along nice and easy. Let's see, and then I'll do a purpley color, and then orange. All right, step one, plug in my numbers. Okay, here's my equation. I'm going to plug in my numbers. Let's say that this is a 5 kilogram object, and it is going 3 positive meters per second, plus, okay, let's see, a 8 kilogram object, and it is going negative 3 meters per second, equals, alright, well, it's still 5, and now the problem tells me that it's going negative, let's see, what's a good one, negative 5. This is still 8. What is my unknown velocity? What is the velocity of B after the crash? Alright, so I would probably add some parentheses just so I don't get confused later. Step 1, plug in my numbers. Done. Step 2, simplify. Alright, well I got to do 5 times 3. Positive 3. So that gives me positive 15. Plus, alright, whatever 8 times negative 3 is. Alright, well I know that 8 times 2 is 16, so this is going to be negative 24. Did I do that right? Mr. Seisler is slightly sleep deprived and doesn't remember his multiplication tables. Oh, good. I can do math. Good, good. Alright, and on this side I got 5 times negative 5, so that's negative 25. Plus, I cannot simplify this. There's nothing I can do there. So I'm just going to leave it 8VBF. Plug in my numbers. Done. Simplified what I could. Done. 3. Move all the stuff that I can to one side with addition and subtraction. Alright. Let's see. I want to get this alone. So the only thing I really need to move with addition and subtraction is this. It is minus 25, so I am going to add 25 to get it to both sides. So now I have positive 15 plus negative 24 plus positive 25 equals 8VBF. Alright. Finish moving stuff to the other side, so this is alone, but this time use multiplication and division. Alright, well, I'm going to divide both sides by 8. This is multiplied together. Divide by 8. Alright, last step. My unknown should be alone on this side, which it is. I now need to simplify this mess to get my final answer. So I got 15 plus negative 24 plus positive 25 equals 16 divided by 8 equals, the positive is important, 2 meters per second. And that is my answer. Alright, at this point, we are done with our collision review notes on page 63. Please turn your interactive notebooks to page 62. where you're going to take a practice quiz. I am going to give you the questions in this video. You are going to look at it, you're going to copy it all down. Then, you are going to have 5 to 10 minutes of silent time, where you guys are not helping each other, you are just solving the problems alone. This is ungraded, this is just to see what you can do. Take 5-10 minutes, your group, to be silent and get stuff done on this quiz. Then, I want you to unpause the video, and I will show you the answers. Here we go. So, the practice quiz works like this. I have 4 collisions for you. 2 of them are inelastic, 2 of them are elastic. For all of these problems, the mass of object A is 0.5 kilograms, and the mass of object B is 0.8 kilograms. 0.5 kilograms is the mass of our dynamics carts, the ones that mysteriously went missing. Just to give you an idea of how heavy we're talking. Alright, for this one, object A starts with a velocity of positive 5 meters per second. Object B starts with a velocity of negative 5 meters per second. After the crash, object A has a velocity of negative 8 meters per second. What's the velocity of object B after the crash? Alright. 2. Positive 5. Negative 2. They then stick together. What's the velocity? 3. Positive 5. What is it? And after the crash, you know it's negative 2 and negative 3. And here, what is it? Where this is negative 5 meters per second, and this, after they're stuck together, is 0 meters per second. Alright, here you go. Please now, pause, and do this alone. Alright, if you're still watching, I'm assuming that you are done. Everyone in your group is done. Yes? Okay. Let's talk about answers then. Number 1. What is the velocity of B after the crash? Well, the velocity of B after the crash should be positive 3.125 meters per second. Number 2. These two things get stuck together. What is the velocity after the crash? Well, that is going to be positive 0.69 meters per second. Ooh. 3. What is the velocity of B before the crash? That's going to be negative 7.375 meters per second. And what is the velocity of A before the crash, such that when they collide, they stop moving? Positive 2 meters per second. Please give yourself a grade out of 4. Write it on the top. This is stuff you need to study for your real quiz tomorrow. Oh, at this point, let's see. What are you supposed to be doing now? Oh, work time. You've got a lot of stuff to be doing for your project. Get to it. Go.